Hey y'all, it's Dr. B. How y'all doing? So today we're going to talk about quadratic functions. Sorry, we're gonna talk about the basic graph, what it looks like. Because if you can learn what these graphs look like, it'll be easier for you to determine how to graph it. So we're gonna do that. Let me flip this. We're gonna do that first. Okay, the graph of the basic functions. We're gonna talk about properties. We're gonna talk about the standard form, often called the vertex form. 5 steps on how to graph, how to find minimum and maximum values, and then we're gonna do a fun example with football and quadratic functions, just so how you can see it relates to real life. And then, of course, the common mistakes and key takeaways. So let's get into it. Okay, cool beans. So the basic graph of a quadratic function is called a parabola. Let's go ahead and just do a t-table. What I'm going to do is I'm going to pick numbers on the positive side of the graph, and then I'm going to pick numbers on the negative side of the graph, just so we can see what both sides look like. So let's do -2, -1, 0, 1, and 2. And basically what I'm doing, I'm going to substitute that in for x. Now remember, when you're talking about functions, we use f of x. If we were talking about equations, we would just use the y. But because we're talking about functions, we use f of x. And so the same rules apply. We're going to take this x and we're going to plug it into there to figure out the value. So if x is equal to 2, then you would say f of -2 would be equal to -2 squared, which is 4. Okay, and then f of -1 would be equal to -1 squared, which is 1. And then f of 0, which would be equal to 0 squared, which is 0. 0 squared is 0, right? And then f of 1 would be 1 squared, which would be 1. And then, of course, f of 2 would be 2 squared, which is equal to 4. Sorry, that was sloppy. So we have our points. We have -2, 4. We have -1, 1. We have 0, 0. And then we have 1, 1, right? And then we have 2 and 4. So let's plot those points. I'll do blue. So 0, 0 is here, right? And then 2, 4, -2, 4, and then 1, 1, -1, 1. Why I went in that weird order, I don't know. So the graph of x squared looks like a U. And mine is not as pretty, but it looks like a U. And as you notice, the y starts at y equals 0 and it goes up. You notice it never hits down here. So what's the range of this particular graph? Remember, your range represents your y value. So the range right here would start at 0 and would go to positive infinity. Now what about your domain? Domain represents your x values. We don't know where this ends up and we don't know where this ends up. And it looks like it just goes straight, but as this graph travels into infinity, you don't know how wide it's going to get. So for the quadratic functions, your x values is always going to be -infinity to infinity, always, because you're literally squaring each x value. So you're going to be able to pick whatever x's you want, but your y value is the one that's going to start at a certain point and go up, especially if you have a graph that opens up or if you have a graph that opens down, which leads us to our next slide. So the graph of a quadratic function is called a parabola. That is the name of it. So when someone says parabola, you want to think quadratic function. Now, you have two different ways that these graphs will open. When the coefficient of a on the quadratic function is greater than 0, then the graph opens up like this. Okay? When it's greater than 0, the graph is going to open up. And then when it's less than 0, it's a negative number, the graph is going to open down. The only thing a cannot be 0. Why? Because if a is 0, you have no quadratic function, because 0 times anything is just 0. So this is the quadratic form, if you want to call it that. If you remember the quadratic equation, that's what you normally use to solve for these, is the quadratic equation. x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Y'all remember that song? Maybe I'm too old, but yeah, that's you would use the quadratic equation to solve the quadratic forms and to figure out what the x-intercepts are. So yeah, opens up or it opens downwards. Cool beans? Okay, now let me draw those again. So if the a is greater than 0, remember the parabola will open up, or if the a is less than 0, the parabola will open down. Now, that's important because you need to know the direction of the graph when you're trying to graph these. But this point here and this point here, this is called your vertex. It's where the graph turns around. Okay, I'm going to put vertex here. Okay, it's where the graph turns around. So the graph comes down and it changes directions and it goes up. The graph goes up, changes directions, and it goes down. Okay, that is your vertex. And the vertex is, when they talk about the vertex, you're going to see HK. HK, HK. You're like, where does HK come from? And I'll show you on the next slide. So when you have, when it's upward like that, you end up having, what do you want to call it? This right here, this is the lowest point of the graph. Okay, when it's open upward, that's the lowest point of the graph. I guess you can see that. And then right here, this is the highest point of the graph, or the maximum point of the graph. And point, when I say point, I'm talking about ordered paired XY. So upward or downward. Now, there is a line when you, if I go back here, there is a line that splits the graph in half, meaning like a symmetric lines where each side would kind of match if you were to fold it across that line. That is called the axis of symmetry, and it's the x equals h line. And you notice the h is the same h that's in the vertex. So you're like, what's the line that splits the graph in half? So for example, if I drew that one this way, you would say, okay, the axis of symmetry would be whatever this x value is, x equals h, because this is your vertex, hk, and the line that splits it in half, that's the axis of symmetry. And it doesn't matter if my graph looks like this, or if my graph, I can erase this one, or if my graph is going this way. Okay, the vertex is still here. Okay, that's still the vertex, which we know is HK, and the line that cuts it in half, that line that cuts it in half, that's the line x equals h. And you're like, well, why is it x equal? Remember, even though the x-axis lays this way, your tick marks go that way. So the x-axis are always going to be these vertical lines, and then your y-axis are this way, which are your horizontal lines. So that's why it's the line x equals h. So now, standard form. This is the different form I was talking about when you're like, where does the HK come from? It comes from the standard form, not the quadratic form. You will hear some people call this, I'm going to put or the vertex form. And the reason why they call it the vertex form is because you literally see the vertex here. Remember, the vertex is HK. You can literally see it in this form. And then, of course, the axis of symmetry is the line x equals h. So that's why they say it's vertex form, standard form. Now, you're probably thinking, well, why is standard form different from the quadratic form? Are they the same? Remember, they are strictly different forms, but they get you to the same graph. Okay, different ways of writing the exact same function is all it is. If it's written in this form, you immediately see the vertex and you immediately see the line of symmetry. You know if it opens up, if it opens down, because if a is greater than 0, it opens up. If a is less than 0, it opens down. So you see more information immediately. When it's in the quadratic form, you don't see it right away. You have to get some points to make it, give you the points that you need to graph it. And then we'll get to this later, but the vertex looks like this. And again, that comes from doing the quadratic formula. The quadratic formula that we did here. This thing here. When you do the quadratic formula, it gives you those values. Okay, and we'll do an example with that. When you look at it, look what form is it in. Is it in standard form, the vertex form, or is it in that quadratic form? Because that's going to let you know which direction you need to go. Preferably you want it in standard form, because why? You can see the vertex, you can see which way it opens, and you can find the axis of symmetry. So determine what form it is so you know which way to go. Does it open upward or does it open downward? What is the vertex? Because that's going to be one of your points. And then remember, to draw any graph, you need at least 2 points so that you can connect the dots, right? For a parabola, you probably want 3 points because you want to see what sides the legs are on. The legs of them, I'll call them legs. So find any x-intercepts, y-intercepts. If you need to do a t-table, do a t-table to get at least 3 points if you can. 4 would be good. And then plot the vertex, plot your intercepts, and then any other additional points that you have found. So let's do an example. So let's look at this one. F of x equals negative 2x minus 3 squared, negative 2 times x minus 3 squared plus 8. What form is this in? Good. This is standard form. Matter of fact, let me come over here. This is standard form or vertex form, right? And then if I were to label everything, this is my A. Sorry. This is my A, right? This is my H. And this is my K. Because remember, standard form, if I go back, looks like this, right? Good. So that's my A, that's my H, that's my K. So we identified the form. Does it open up or does it open down? Good. It's going to open down. A is less than 0, so it's going to open downward. Okay, so it's going to go in this direction. So that's good. What is the vertex? We said the vertex is HK, right? So our vertex is HK, which is 3, 8. Okay, so far so good. So we found the vertex. We know the form. We know which direction it opens. We found the vertex. Now, let's find our x-intercept and our y-intercepts. Okay, remember this is where you set y equal to 0, and this is where you set x equal to 0. I'm not going to have enough room to do it on here, so let's go to some scratch paper. Okay. Let's find our x-intercept, y-intercept. For the x-intercept, we set x equal to 0 and solve for y, correct? I'm sorry. For the x-intercept, we set y equal to 0 and solve for x. I said that totally backwards. So let's find the x-intercept, and we're going to set y equal to 0, okay? So that means we have 0 equals negative 2 times x minus 3 squared plus 8. So far, so good. Now, I can't take this negative 2 times that. I need to square that first. So let's come over here and then let's square that. Okay, so if I have x minus 3, sorry, that's ugly. If I have x minus 3 times x minus 3, do the FOIL method. So first, outer, inner, last. So that's x times x plus a negative 3x plus a negative 3x plus a negative 3 times negative 3, or a negative 3 squared. So that gives me x squared minus 6x plus 9. Y'all see that? X squared minus 6x plus 9. So this is going to replace this because we have now squared it, okay? So now we have 0 equals negative 2 times x squared minus 6x plus 9 plus 8. So far, so good. So what I did, I took this, I squared it by doing the FOIL method. When I did the FOIL method, I came out with that, okay? Now I can take the negative 2 times everything because that squared has gone away. So I have 0 equals negative 2x squared, We have a negative 2 times a negative 6x. That's going to be a positive 12x. And then we have a negative 2 times a negative 9, which is going to be what? A negative 18, because 9 times 2 is 18, right? And then let's add our plus 8. So far, so good. So we did this part here, and we brought the 8 down. All right? So now can we, yes, we can combine like terms. We have a negative 18 and a positive 8. So we have 0 equals negative 2x squared plus 12x minus 10. Because negative 18 plus 8. Look, we checking our, look, we got our calculator. We checking negative 10, right? Okay, good. Now, we have to factor this, but I think we can simplify it. If you notice, every single one of these terms can be divided by the 2. And when you're talking about equations, whatever you do to one side, you have to do to the other side. So let's divide. If I divide this side by negative 2, I need to also divide this side by negative 2, because whatever you do to one side of the equation, you have to do to the other side of the equation. All right, so these 2 will divide. 2 will go into 12 6 times. 2 will go into 10 5 times, right? And then we know 0 divided by anything is just going to be 0. So let's do that. So we have 0. These divide. So we're just left with 1 times x squared. A 12 divided by a negative 2. That's going to give us what? That's going to be a negative 1. And then I'll just put a positive 6 here. 12. That's going to, so 6 divided by negative 1. That's going to be a minus 6. And then a negative 10 divided by a negative 2, that's going to be 5, right? I'm writing sloppy. Please forgive me. Okay, 0 equals x squared minus 6x plus 5. Now we got to factor that, because we need the x-intercepts, right? So when we factor that, if you remember factoring, do you know what two numbers we're going to have? Yeah, x minus 5. X minus 1. Very good. So are we done? Nope. Now we got to set them equal to 0 so we can finish getting our x-intercepts, our x-intercept points, right? So then we have x minus 5 equal to 0, and then we have x minus 1 is equal to 0, okay? And then we're going to add 5 on both sides. When we do that, we have x equals 5, right? Because that subtracts out. And then same thing here, we're going to add 1 on both sides. And when we do that, this goes away, so we have x equals positive 1. So this is the 0.50, and this is the 0.10. So when y is equal to 0, x is equal to 5, and x is equal to 1. So when we come back here, we have, let me move this down. So we have 5, 0, and 0, 1. So far, so good. And this was our vertex, was 3, 8. We put all our points in blue. We know it opens downward. Now, let's go back to our scratch paper. Let's find the y-intercept. Now, for the y-intercept, you set x equal to 0, and you solve for y. So for the y-intercept, okay, we're going to set x equal to 0. So we're going to have, now, y and f of x are the same thing, okay? So what we're looking for f of 0. F of 0, right? That's what we're looking for. So f of 0 is going to be equal to negative 2 times 0 minus 3 squared plus 8. We're setting x equal to 0 so that we can find y and get our y-intercept. Okay, so now that's going to be negative 2. 0 minus 3 is negative 3 squared plus 8, because if you start at 0 and you drop to negative 3, you drop minus 3. Negative 3 squared, negative 3 times negative 3 is a positive 9. Okay, then we do negative 2 times 9, negative 18 plus 8, and we know that's going to be negative 10. Okay, cool beans. So this is the point when x is 0, y is negative 10. Make sure I don't write into the thing. Okay, so that's that point. So let's go back. And so we have the point 0, negative 10. Cool. I think we have enough points. We got 4 points. We got the vertex, 2 intercepts, and the y-intercept. So let's go to our graph and let's graph this. So we know it opens downward. Our vertex is at when x is 3, y is 8. So that's our vertex at 3, 8. And then we have x-intercepts when x is 5, y is 0. When x is, I wrote that backwards. Why did y'all let me write that backwards? 1, 0. Y'all probably like, whoa. All right, 1, 0. Okay. So, oh, and then our y-intercept, I don't have a 10, 8, 9. We're going to guesstimate. That's about right there. Yeah, that looks good. Okay, so let's draw this leg of the parabola. And then let's draw this leg of, okay. Draw this leg of the parabola. It's kind of ugly. But y'all get the gist, right? 5, 0. And then this is 1, 0. And then this is 0, negative 10. So that's why I say the form matters. If you already have it in this standard form or this vertex form, you got the vertex, find the x-intercepts, y-intercepts, and then you keep it moving. Okay, easy. Now let's look at another one that's not in that form. Now this one is in which form? Good. This is, I'll just say quadratic form. This is in quadratic form. So when it's in quadratic form, you still, let me show you. When it's on quadratic form, your a, this is still your a. So here I'm going to put a equals 1. Some people, when you don't see a number there, it's really, it's just a 1. Because remember, a can't be 0. So you have a, what do you call it? Ax squared plus bx. This is b. And then this is c. Okay, quadratic form. F of x equals ax squared plus bx plus c. You can, when it's in this particular form, you don't immediately see the vertex, but there is, and I think we had it, where was it? Here. So this is how you find, that's how you find the vertex. See if it'll let me copy this. Okay. I copied the vertex, so we have it over here. Now, what direction does this graph open, up or down? Good. It's going to open upwards because a is greater than 0. A is positive, so it's actually going to open upwards. So that's good. Let me see if I can move this, make it smaller and move it right there. Yeah, okay, that's fine. So boop, boop, boop. We know it's going to open upwards, so I'm going to put open upwards. Right, so we know it's going to do something like that. Okay, so now let's find the vertex. Let's find the vertex. So now, remember the vertex we have, that's where we're going to use this particular, formula here to find the vertex. Matter of fact, since I already got it, let's just put that there. So we're going to use that formula there to find the vertex. So it says the x part is negative b over 2a, right? And the y part is f at negative b over 2a. Okay? The vertex, or if you want to say, we on the other formula was HK, but this one we're talking about the X and Y because we're talking about the actual ordered pair. So that's going to be what? Negative 4 divided by 2 times 1. Y'all see that? Negative 4, because that's the B, and then that's the A. So then that gives me negative 4 divided by 2, which is going to be what? Negative 2. Yeah. Okay. Cool beans. And then now we have to find the y, which this is going to be equal at f at negative 2. Y'all see that? F at negative 2, because that was the x value. And what that means is you have to take the quadratic formula and substitute negative 2 into every x. So that's going to be, move that over. I think I moved my vertex with it, didn't I? So that's going to be negative 2 squared plus 4 times negative 2 plus 1. Y'all see that? Right here. So for every x, you got to plug in negative 2. For every x, you got to plug in negative 2. So then negative 2 times negative 2, that's going to be positive 4. 4 times negative 2 is going to be a negative 8, and then plus 1. And then negative 4 plus 8 is going to be a minus 4, right? A minus 4 plus 1. And then a minus 4 plus 1 is going to be a minus 3. Do y'all see that? A minus 3. 4 plus negative 8 is a negative 4 because the 8's the bigger number. And then negative 4 plus 1 is going to be 3. So our vertex is negative 2, negative 3. Negative 2, negative 3. Negative 2, negative 3. And the graph opens upward. So negative 2, where x is negative 2, y is negative 3. So that's right here. And we know the graph is going to go this direction. So we just got to figure out the rest of it. So now we need our x-intercepts, right? And our y-intercept points. That's the next thing. So let's go our scratch paper. Now, you notice here I had the quadratic formula. If you try to factor this, is it factorable? Meaning, are there two values where you have your x and your x? It's going to be a plus and a plus. That if you put those numbers here, what two values that if you add them together will give you the 4x, and if you multiply them will give you 1? Well, the only numbers that give you 1 is 1 times 1. But 1x plus 1x, when you add them together, that's 2x. That's not 4x. So this is not factorable. And because it's not factorable, you need to do the quadratic equation, the quadratic formula, You do the quadratic formula in order to figure out what the x values are. So this is probably going to have some radicals in it. So let's go through this really quick. I listed the A, the B, and the C, okay? So yeah, because this is going to be, when you're finding the x-intercept, this is going to be 0 equals x squared plus 4x plus 1. That's when we're finding the x-intercept. The problem is this is not factorable. So I have to use the quadratic formula to figure out what the x-intercepts are going to be. Okay, cool beans. So, sorry, I keep doing that. I'm trying to get in the habit of not doing that, of putting my head all in the camera. So this is going to be, if we substitute our B, our C, and our A into here, so then that's going to be minus 4, if I get my pen right, minus 4 plus or minus the square root of 4 squared minus 4 times 1 times 1. Y'all see that? All over 2 times A. Okay, so I changed the color so you can see where we substituted the values. Okay, so these values here were substituted in here. So now if I keep going, I end up with a minus 4, right? Plus or minus 4 times 4, or 4 squared. 4 times 4 is 16, minus 4 times 1 times 1. So 4 times 1 is 4, times 1 is also 4. So that's the square root of that minus 4, and then divide it by 2 times 1, which is 2. Notice it's everything is divided by the 2 times a, okay? So then that gives us negative 4 plus or minus the square root. 16 minus 4 is what? 12? 4, 5, 6. Yeah, 12 divided by 4. Oof. So this is negative 4 plus or minus the square root of 12. That's the square root of 4 times the square root of 3. But we know that the square root of 4, that's equal to 2. Y'all see that? So let's come up here. So that's going to be negative 4. This was divided by 4. Negative 4 divided by plus or minus 2 times the square root of 3 divided by 4. So now I'm going to write it like this. Negative 4 divided by 4 plus or minus 2 to the square root of 3 divided by 4. So all I did was split the 4 between the two numerators. And then if I continue to simplify, this is going to be, y'all, do y'all see what I did wrong? Look at it. What did I do wrong? Where did that come from? My 2 magically changed into 4, and y'all didn't say nothing. Oh, I kept saying 4 so much that I was like 4, 4, 4, 4. Okay, this should be 2. That should be 2. Y'all see that? That should be 2, 2, 2. Better? Better. Okay, now, negative 4 divided by 2, that's going to be a negative 2, plus or minus, and then these 2 will divide, right? This was a 1, that became a 2. And it looks like it's, what, times 2 plus or, 2 plus or minus the square root of 3. 2 plus or minus the square root of 3. So x is equal to negative 2 plus the square root of 3, and x is equal to negative 2 minus the square root of 3. So if I were to write those as ordered pairs, they would look like this. And you're like, well, what do those equal? Put them in your calculator, because you got to plus the square root, square root of 3. Looks like this is approximately 0.2679. Oof, negative 2 minus the square root of 3. This is approximately negative 3.732. We're guesstimating, y'all. Yeah, we're guesstimating. Okay. And then the y-intercept. When you find the y-intercept, you set x equal to 0. Do I have room right here? You couldn't even see that, could you? There we go. Okay, so for the y-intercept, you set x equal to 0. So watch. If you're looking for f of 0, that's going to be 0 squared plus 4 times 0 plus 1. 0 plus 0 plus 1. That's just 1. Okay, so when x is 0, y is 1. Okay, so let's go back up here. We're going to have to guesstimate on this because these numbers are just weird. So we have negative 2, negative 3. Now remember, I told you your other thing that you can do is just plug in. You can do a t-table. So that's another thing that you can do if you don't like doing the quadratic formula. I did the quadratic formula here because I didn't know how long it's been since you've seen the quadratic formula. So that's why I did it here. But we're just guesstimating. So negative 2, negative 3. Our y-intercept was 0, 1. Okay. Our y-intercept was 0, 1. So when x is 0, y is 1. So that's going to be one leg of it. And then the other, we have negative 3.732. 3.7, so almost 4. So we're going to kind of guesstimate that. We're going to say right in there, like in between the 3 and the 4. So really, this graph is going to look something like this. And see, our other x-intercept was like less than, like barely, not even close to 1. So it's kind of right on the 0. But again, we're guesstimating. Okay, so that's sort of what the graph looks like. Again, if you don't like doing the quadratic formula, you don't have to. You could do a t-table, and you'll say, okay, well, Dr. B, if I do a t-table, what points can I pick? Well, you can pick any x value you want. Like, for example, if x was equal to -1, what does y equal? Like that. If x is equal to -2, what does y equal? You could do a t-table and get the values and still draw the graph. I just wanted you to see a quadratic formula. Okay? Cool beans? I hope this is making sense. Remember, at any point, you can leave a question, and then we can go through that. Okay, so remember we talked about at the very beginning, we talked about the highest point, the vertex being the highest point or the lowest point. That's where your minimum values are. So typically you would say that depending on which way the graph opens, you will have a minimum value of blank at a location. So the minimum value occurs at a location. So when you're talking about a minimum value, that's where the a is greater than 0. So that means you're going to have your parabola is going to look this way, and then here's your vertex. So this is your minimum. This is your minimum value, okay? Or your minimum point. I'll say minimum point. Okay, so when a is greater than 0, the parabola opens upwards. That is your minimum point. And you say, if they say, what's the minimum value? Not the minimum point. The minimum point is your vertex. What's the minimum value? You say, well, my value is k, depending on which form you're looking at. If you're looking at standard form, it's going to be the y value of the graph, because the y value tells you max or min. Okay, max or min is your y-axis. That's your y-axis. And your x-axis tells you located where. So I have a minimum at y equals whatever at this x point. Okay, so your minimum value occurs at the y value of the graph, and it occurs at the x spot on it. So the location is x, the max or min is y. Let me write that down. So the location is x, and the max or min is y. And that's when you're talking about on the graph. So if a was less than 0, you would actually have a parabola that goes this way. This would be your vertex. Right? And then this would be a max point. Okay, that would be a max value. I'm running out of room. But that would be your maximum point. So you would say I had a maximum point at this y value, and it's located at this x position. Okay? The location is the x. Where is it located? Where does it occur? That's the x. And then is it a max or a min? That's your y value. What is the y value? Okay. And I showed you two different forms here, because sometimes depending on what form you're working with, that's what's going to, but as long as you graph the equation, you can see, is it a high point? Is it a low point? That's where the y is. And then where does it occur on this side of the x, this side of, like where does it occur? That's your x value. I hope that makes sense. So let's look at this one without graphing. Okay, without graphing, and it's in this quadratic form. So we know that a cannot be equal to 0, but we can find the vertex here. Now, does the graph open up or open down? Good. That's our A, right? So this is our A, this is our B, and this is our C. Because A is greater than 0, we know that our graph is going to open upwards, right? I'll do it right here. We know our graph is going to open upwards. So if our graph opens upwards, it's going to have a minimum, a low point or a minimum value. You'll see that? So this will have a minimum value because it opens upward. So it's going to have a low point. Now, it has a minimum value, or it has, I'm sorry, it's going to have a minimum point. Let me change this to minimum point. That's the minimum point. At the minimum point, you have a minimum value and a location of that minimum value. Well, where does the minimum value or maximum value? So I'm going to circle minimum value because that's what we have. Now, you're like, well, how do I figure that out? Again, if you can find the vertex, right? If you can find the vertex, this value tells you the location of the max or min value. Okay? So the X tells you the location of it. So let's do that. So I'm gonna, do I have scratch paper? Yes, very good. So let me copy this. Cool beans. So let's find the vertex. And then this is our A, this is our B, and this is our C, right? A, B, and C. Cool beans. Okay, so let's find this value. So our X is negative B over 2A. So that's going to be a minus, and then I'll say over 2. So minus 16, and then 4. Y'all see that? I put the A, and I put the B, all right? So a minus 16, that's going to be a positive 16, and then 4 times 2 is 8. So 16 divided by 8 is 2. Easy? Mm-hmm. And then to find the Y value, we take F at this point. Okay, so let's find our Y. So Y is equal to the same thing as F at negative B over 2A. So that's going to be equal to F at, we found that negative B over 2A was 2, right? So that's going to be at 2. Okay. So that means take 2 and substitute in for every x that you see in the quadratic equation. So let's see. We have 4. That number is going to be squared minus 16 times x plus 1,000. So far, so good. And we're saying that 2 needs to be substituted into every x. Okay. So then this becomes 4 times 4, right? Minus, well, I'll keep writing it. 16 times 2 plus 1,000. Okay. And then this is going to be what? 16 minus 32 plus 1,000. And then 16 minus 32 should be a minus 16, right? Plus 1,000. And then a minus 16 plus 1,000, 984. Okay, so our vertex, do that in brown or yellow. So our vertex is the point 2, 984. So let's come back here. So I'm going to put our vertex is 2, 984. So the graph opens upward, so it's going to go up and keep going. The domain, we know, is always negative infinity to infinity. But where does the graph start? This is our vertex. Our vertex is the lowest point, right? So where does the minimum value, does the function have a minimum value? Yes, it has a minimum value of 984. Where does the minimum value happen? It happens at x equal 2. Our minimum value of 984, because our value is where it the value at that point. And where does it happen? It happens at x equals 2. The domain of all quadratic equations, we said this at the very beginning, is negative infinity to infinity, because the arms go up. You don't know where those arms stop, right? And then the range is where does it start and where does it end up. The range is it starts at 984 and it's going to go to positive infinity, because 984 is the minimum value, and it's going to shoot up because the graph goes up. Easy? I hope this is easy. Okay, so now let's do our little fun example. A ball is thrown upward. A ball is thrown upward from a height of 6 feet. The height of the ball represents f of x, which makes sense because remember when you're talking about your graph, max height is your y. That was very ugly. Remember, y-axis is up and down. X-axis is across, okay? So the height of the ball is represented by f of x in feet. Here is the function that they use to model the trajectory of the ball. And it says where x is the ball's horizontal distance from where it was thrown. Now I have a football player here, because football player can be 6 foot, quarterback. He throws it from the 6 feet, throws it from 6 feet. It's going to go up and then it's going to eventually fall, right? So when he's throwing the football, I guess I should have did a video. He's going to throw it and it's going to fall. Hopefully a touchdown. You never know. But this is the function that is used to model that. Now, before we even start looking at the graph and what it looks like, which way is this? This is a quadratic function. Notice it's in quadratic form. Which way is the graph going to open, up or down? Down, right? Because this is negative. So it's going to go like that. And does that make sense for the question? Yeah, because if he's throwing the football, he's got to throw it like that. He's not going to throw it underhand, right? You throwing it over. So it's got to, so that makes sense that it's going to be, that it's going to open downward. You see that? Okay, cool beans. So let's go through some questions. So it says, what is the maximum height of the ball and how far from where it was thrown does this occur? Remember, your maximum height is going to be how high, what's the value of y, and then how far it goes, that's your x-axis, because your x marks the spot. X marks the spot. How high was it when it hit that spot? So it says, what's the maximum height of the ball and how far from where it was thrown does this occur? So what you want to do is you want to do the same formula we just did, where we did the finding the vertex. Let me go back and grab that because we kind of need it, don't we? Let me grab that. Whoop. Okay, so let's copy. Make sure y'all can see that. Okay, so yeah, we're going to need that. All right, so if I write down the pieces, our A is negative 0.8, right? Our B is 2.4, and our C is equal to 6. All right, and it says, what is the maximum height of the ball and how far from where it was thrown does this occur? So they said when the ball is thrown, it was thrown from 6 feet. So it's going to start, if I do some tick marks here, 1, 2, 3, 4, 5, 6. So it's going to start here. This is the point 0, 6, which if you notice, that's a y-intercept. Do y'all see that? And it makes sense because if you set x equal to 0 here, you get 0 plus 6. You get the point there. So the ball is going to be thrown from here 6 feet, and it's going to keep going, and it's eventually going to come down. But they say when the ball is first released, what's the max value? How high did it go? And at what X location was it that max value? So that's what we're trying to find. That's why it's kind of like, that's why I called it a real world example, because you can kind of see how it works. So that means we need to find the vertex, right? So if we find, let's find how high it went. The height of it is going to be the Y value. And how far is going to be the X value, right? So this is X equals negative B over 2A. So we need this first, right? So negative B over 2 times A, right? Okay, so negative 0.8 and then 2.4. So that's going to be a negative 2.4, and then 2 times 0.8. That's going to be 1.6. And when you take negative 2.4, negative 1.6, because it's 2 times negative 0.8. And then when you take negative 2.4 divided by negative 1.6, you get 1.5. And that's in feet, I believe. So if I do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. It looks weird on the graph because it's like it's going to be like right here. I guess some people would say that's how far Dak would throw it anyway. Okay, so that's our point there. And then let's find F at, we'll do that in purple. F at 1.5. Because that's negative B over 2A. We found it to be 1.5. So that means take it and substitute it in this X. For every X, you need to put 1.5. Okay, I switch the X and the Y around real quick, okay? So that's going to be a negative 0.8, right? Plus 2.4 plus 6. Let's see. So 1.5, 1.5, and this is squared. So I'm going to put this whole thing in my calculator to see what I get. And I think I wrote it, so this is a negative 1.8 plus, yeah. Plus 6. All right. So negative 1.8 plus 3.6 plus 6. That gives you 7.8 feet. Okay, so that means the height was 7.8. So that's about where, like here, and then if this is 7.8 and 1. So the ball kind of went up, and then it was on its way down, I'm assuming. So this is 1.5, 7.8. Okay, so it had a max. I'm going to say it had a max height of 7.8 at X equals 1.5. So max height at 7.8 where X equals 1.5. How far does the ball travel before it hits the ground? Well, remember it started, where did it start? It started at 6, right? 1, 2, 3, 4, 5, 6. Started here. And 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Basically, they're saying when the ball, and we saw it, right? We said it went up and then it's going to eventually come down. Now here I made a huge assumption. I don't know that that's where it's going to fall. I just drew the picture. So you got to be careful with pictures, the way you draw it. So we know it goes up and we know it reaches a maximum point, but eventually it's going to come down some kind of way, right? So when the ball hits the ground, what's the y value? 0, right? When the ball finally hits the ground, when it hits the ground, your y is going to be 0. So that means set this equal to 0 and solve for x. You see what I'm saying? So when the ball hits the ground, your y is going to be 0. When the ball hits the ground, your y is going to be 0. So then set y equal to 0 and solve for x. That's the x-intercept. When does it hit the ground, right? So that means what? Quadratic formula, right? Do I have enough room? I think I have enough room. So x equals negative b plus or minus, do that, different color. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a, right? And our a is negative 0.8, our b is 2.4, and our c is equal to 6. Okay, so let's plug and chug. So we're going to have a minus. Don't forget that minus. And then we're going to square it for a and c, right? And then it's going to be all over. Okay, so far so good. So this is obviously a negative 2.4 plus or minus. Let's do all this underneath. So you have 2.4 squared minus 4 times negative 0.8 times 6. I get 24.96 all over 2 times negative 0.8, negative 1.6. So you have negative 2.4 plus or minus, oh, we can put that in the calculator. Let's see. So if I separate this, you're going to have negative 2.4 plus the square root of 24.96 divided by negative 1.6, right? Or negative 2.4 minus, because it's plus or minus, minus the square root of 24.6 divided by negative 1.6. Okay, so it's going to be or. Put or. Okay, so let's see what values we get. So negative 2.4 plus the square root of 24.96 divided by negative 1.6. This gives a negative 1.62, and then negative 2.4 minus the square root of, negative 2.4 minus the square root of 24.96 divided by negative 1.6. This gives you 4.62. Now, you're like, well, how do I know which one to pick? Well, the ball was thrown from 6 feet and it went that way. You notice you don't even start over here because your x-intercept is here, right? Our vertex was somewhere right here. So our graph is literally doing something like that, but you don't throw the ball backwards. You see what I'm saying? You throw the football forward. So we have to get rid of the negative value. The x can't be a negative value because he didn't, unless, well, it's the Cowboys. But anyway, you throw the ball forward so we keep the positive value. So the ball hits the ground, because remember this is y equals 0. The ball hits the ground at 4.6.2. So my picture was almost kind of correct here if you look at it. So so almost here. And then remember it was 1.77 something here. So that means this graph, it goes up and then it comes right down here. Okay, that's what it's looking like. And then the other side that we don't see is probably doing something. You know, you don't do anything with this side. Okay, let's just say that. We don't do anything with that side. All right, cool beans. I hope that's making sense. This says graph it. So let me get my points. I have 0, 6, right? 0, 6, that's here. And then we said, what was the vertex? 1.5, 7.8. So I'm right here. That's our vertex. 1.5, 7.8. So 1.5 would be here, and 7.8. That's gonna be really close to 8, ain't it? So we'll put that right here. So we know it goes up, and then they said 4, when y is 0, x is 4.62. So hold on, we're gonna cross this one out, because you don't throw the football backwards, you throw the football forward, and this is where it hits the ground. Okay, so when y is 0, x is like 4.62. So when y is 0, x is like 4 points. So it's going to go like this. Okay. So our vertex, 1.5, 7.8. Our y-intercept is 0, 6. And our valid x-intercept, we had 2 of them, but remember, you don't throw the football backwards. It's when 4.62. Yeah, 4.62, comma 0. Okay. This is our graph. Okay, this was our vertex. This is our 4.62, comma 0. And this was 0, comma 6, okay? And this was a maximum point. Very good. I know that was a long lesson, but very good. So common mistakes, not knowing the difference between the quadratic form and the standard form. You want to make sure that you understand and you know the difference between those two forms, because you'll immediately know how to graph the equation the quickest and what direction you need to go. Another mistake is just eyeballing, like, oh, it opens upward, here's my vertex. You saw how I was forgetting the negative sign sometimes, or leaving numbers off. You want to write it down so you can see it. That way you can easily spot any mistakes. And then not knowing the quadratic formula and how to use it correctly. Remember, everything is divided by 2a, and the b has a minus in front of it. Okay, so just follow step by step, and then double check behind yourself to make sure you get it right. Okay, pay attention to each form, because the form, again, it's going to tell you immediately, can you just pull the vertex and the axis of symmetry and up or down, or do you have to do the quadratic formula to find your x-intercepts and y-intercepts? So make sure you understand the form. Don't eyeball. Write everything down, write everything down, write everything down. Trust me, because it'll help it stick in your brain. Of course, you should be able to complete all of your assignments with success right now. Some questions may be harder, or some questions may be easier. Just follow the steps that we did in the video, and it should work out fine. And anytime that you have any questions during this video, definitely leave a comment. Reach out to me. Let me know how I can help, because I am always happy here to help. Okay, guys? Until next time, see y'all. Bye.